To the second of the series of videos on learning Python 3. Today we're going to be taking a look at variables, which we briefly looked at in video 1. We had a variable called name, which was where we took the input of whatever we typed our name to be, and we had a variable called place. Both of those were just alphanumeric text, which I think I mentioned in the video known as strings. So there are four main commonly used types of variables that you will use, and they are integers, floating point numbers, strings, and Boolean. So strings we've already seen, that's just alphanumeric text enclosed in a set of opening and closing double quotes. That's how it knows where our text starts and where our text ends. We have two types of numbers. We have integers, which hopefully you know from maths are basically whole numbers. They can be positive or negative, but they do not have decimal or fractional parts. And we have floating point numbers. Those are the numbers that do have decimal or fractional parts for us inside the computer. And then our fourth data type is known as a Boolean, and it can only be set to either true or false. So these are the four types. Today we will be looking at numbers and some of the things that we can do with them. So what are the operators that are available to us with maths or with numbers? And these are some of the common things that you are likely to want to be able to do with a number. You're likely to want to be able to add, subtract, multiply, divide, or raise to the power of. I'll come to this bit with the division in a second. So assigning a number to a number variable inside Python is as simple as writing the name of the variable, in this case a, and the equal sign or the assignment operator, as you should get in the habit of thinking of it as, and then the value you want to assign to it. So here we're taking the number 10 and we assign it to a variable called a. Here we take the number 4 and we assign it to a variable called b. I want to add those two together, so a plus b, and it will print out 14, the 10 plus the 4. If I subtract, so 10 minus the 4 will give me 6, multiply 10 times the 4 will give me 40. In the division here, you see there's a few different things going on. So floating point division, a divided by b. All right, 10 divided by 4 does go 2.5 times, which is what this prints out. All right, 4 times 2.5 will give me 10. Okay, the division is simply the reverse of the multiplication after all, but the interdivision is slightly different. So with two slashes, 10 integer division symbol, the number 4, and basically this is asking how many. This is like your primary school long division style that you might be used to. How many times does the 4 go into 10? Well, 4 goes into 10 twice, and there is 2 left over, right? Because 2 times 4 is 8, and so there's 2 left over, and that is what the remainder is. Right? So if we had 10 divided by 4, what's the remainder? Right? It goes twice with 2 left over, and so that's what this symbol is basically saying. If we were to do this division, what would the remainder be? And then finally we have the exponent. 10 raised to the power of 4 is 10,000. So let's take a look at what this looks like in REPL. Right, and so if you start with a blank REPL, and I quickly type some of this out again. Now you'll notice this time I'm not putting in the spaces that I had there in the slides. It works just fine without the spaces. Now we're just there to make it easier for you to see what's going on. So now if I play this piece of code, we get the numbers that we were expecting: 14, 6, 40, 2.5, integer division is 2, remainder is 2, and then I forgot to do the exponent. Right, but now if I change some of these numbers, like if I change this to 11, how would we expect these numbers to change? All right, we expect the addition is going to become 15, the subtraction is going to become 7, 11 minus 4. The multiplier is going to become 44, 11 times 4. The full normal division is going to become 2.75. And this is why I wanted to illustrate what's going on here. The integer division, how many times does 4 go into 11? It still only goes twice, but this time there is 3 left over. All right, and now if I change it to 12, we expect that it's going to go 3 times with 0 left over. Okay, so that's just so you know, and this time we can see that the normal floating point division is telling us 3.0, so it's going exactly 3 times. So just so you can see the difference between how the two divisions and what the modulus or the remainder operator are doing. So these are some of the mathematical things that we might be able to do, or might want to do. Now, you don't have to assign all the numbers to variables for this to work. Rather than just adding to it, let's just start from scratch. Right, so I could do 9 plus 3, and that would be perfectly valid. That will give me the number 12. All right. I can do a mix and match. I can do, let's make n for number equal 9, and I can replace that 9 with an n, so I can do a variable plus a regular number, and again we get our 12. Okay, so you can mix and match the two around. Here's an interesting question for you. If I had a variable, let's see, 2, 4, and 3, and then I had A plus B times C. The question for you is, what will that equal? There are 2 different things that this could equal. This could be A plus B, which is 2 plus 4 is 6 times 3. 6 times 3 is 18. However, if you are a maths student, you should be aware of a thing known as PEMDAS or BIMDAS or BODMAS or one of those kinds of things, which tells you what the order of precedence of mathematical operators are. And by that rule, we should do this multiplication before we do the addition. So we should do B times C, which is 4 times 3, which is 12, and then we add the A. And so the question is Python BIMDAS or PEMDAS compliant? And the answer to that question is yes. Right? It looks at this and it's smart enough to detect that there's a multiplier there and that it knows it has to do that multiplication first. What happens if we wanted it to do the addition first? Well, just like regular PEMDAS, I have my print statement here. I can use a set of brackets to override and do the addition before doing the multiplication. And so you'll see we get the 14 plus the 18. Again, these spaces are not necessary. I'm just doing them there so you can see what's going on. It will work just as well if I compress it all up like this. But you'll notice it's a little harder to read. All right, so we have PEMDAS compliant maths. What happens if I want to ask the user a number question and then do something with that? Well, it just so happens we can do that. We can use the same input command that we were using in the previous video. Now, the catch is let's move that out of the way. All right, so the only catch is, at the moment, if I don't do anything else with this, we can't tell here as yet, but this A is actually a string, not a number. Even though I've typed in a number, right, the input function will always return a string. It will return the alphanumeric, whatever it is that you've typed, up until you pressed the enter key. And so we need a way of being able to tell Python that we're going to treat this thing like a number. Okay, so for instance, if I was to do B is equal to A plus 1 and then try to print out B, or I wanted to say, let's say your number was, right, that was A, and then And then I want to print out the next number is this is going to crash. Let me just show you why. So if I type in 6, we get an error, must be string, not integer. And that's because we're trying to do maths on something that Python has put a string into A, but then we're trying to do a mathematical calculation on it here, and you can't do that on text. It doesn't know how to treat the text, so we have to tell it to make A be a number, and so we just put the word int as a short for integer around the brackets. We create a set of brackets for it, and we put the input command in that. So we're basically saying whatever this function returns, we're going to now treat it as an integer and assign that to A. So now when I hit play and I type my number 7, your number was 7, the next number is 8. It behaves as I expect. Now that int command can either be put around the integer, or perhaps I do want A to be a string, in which case I can just override it when I'm doing the mathematical operation, and it will behave exactly the same way. All right, your number was 34, the next number is 35. But I need to remember in my head that Python is treating A as a string, and it is treating B as a number. So one of the things that we would tend to do when we are programming is we might, as part of the name, put in a hint to remind ourselves whether it's going to be a number or a string or something like that. So I would, when we get into more complicated programs later on, I might, for instance, use a little lowercase s as the start of a string. So I would call it s name, so I know that it's a string. If I'm inputting in, what is your name? You could use n for numbers, okay? But probably for the moment, just using lowercase letters for your numbers is fine for these very early days. But we will have to, later on, start thinking carefully about how we name our variables. Right? You wouldn't want lowercase a, lowercase b are too similar to have different types of data in them. But that's enough for numbers for now. So we've done printing, we've done inputting, and you've got the mathematical operations. So that is enough to do the first couple of sets of exercises that are available within Replit. And so if you created your Replit account using your invite URL that I sent you, you should have a student tab that appears. And you should find yourself enrolled in a class that I created. And inside there, you will see there's this thing called assignments. They're not really assignments, they're just practice exercises. All right. And so chapter 1 exercises, or 1.1, 1.2, 1.3 through to 1.7. Whoops, I just clicked on one by mistake. And then you've got chapter 2, so 2.1, 2.2, 2.3. You should now be able to do the 1 points, or chapter 1, and the 2 points, or the chapter 2. All right. There's quite a few there for 2. And then for the next video, we'll introduce the if-else that you need for chapter 3. So let's have a go at quickly practicing one of these together, and then you can have a go at doing some of these yourself. So if I go to 1.1, I've already completed this one. Let's do one that I haven't done, where it doesn't just come up and show the code that I've done. Right, you'll see here on the side, it shows what the status of your progress is. So the green tick for completed. So 1.2, all right, write a program that shows the length, that reads the length and the base, so read the length of the base and the height of a right angle triangle and prints the area. Every number is given on a separate line. If I scroll down, we have our formula, area of the triangle equals half base times height. And so the example input, it would be the number 3, the number 5, and we need that to output 7.5. So we have here an example showing the input. B for base, input. So let's take in a number and turn it into an integer and store that into B. So I'm going to add to this, we're going to have a H, and we will turn that into an integer as well. Now, the only catch to be aware of with these exercises, generally they will not want you to include a prompt on the input. If you do, the automated marking won't work properly. Okay, it's not a problem with Python, it's just a problem with the REPL website and the way it's designed its thing to automatically mark your code. So if we put in here, base height, I'll illustrate what I'm talking about. All right, this part won't work. And just also to quickly comment here on the comments, a line starting with a hash is basically, it is just a comment. It is there for the programmer to leave little notes behind to help them understand what their program is doing. So whenever you see a line with a hash, that's what that is for. So here, print, all right, so I want half times the base times the height. And if I print that out, and let's run. All right, so down the bottom here, base. So if I put in a base of 6 and a height of 10, we get 30, which is what we're expecting. We've halved the base. So half times the base, which turns that into 3 times, and then 3 times the 10, and turns it into 30. Okay, so that works. But if I go to submit, the auto marking says output mismatch. Okay, what's wrong? Teacher's input was 3 and 5. Teacher expected to see 7.5. Your output, base question, height question, 7.5. So you see that it's actually the little prompts there that we had there for the input are confusing it. It's only designed to actually look for the answer as the only thing being printed. So I can't give it a prompt. So let's come back here to my little inputs and remove these strings. It makes it a little complicated because it means you've got to remember the order of the inputs and everything else. Okay, the program will still run just fine, except now we don't. We have to realize, okay, this is actually stopped and prompted waiting for a number. I have to think, okay, type in a 4, type in an 8, and there's my output, which is 16. But the auto marking will work fine. So if I click submit, it does a whole pile of tests. It says I've passed all the tests and I can submit my program. And when you click submit, it will send me a notification letting me know that you have completed it. So that is doing numbers, and you should now be able to do, like I said, all the chapter 1 and the chapter 2 exercises. So all the best with that, and I will see you in the next video.